everyone, my name is Anthony Nathaniel, and in this episode of Crash Mathematics for Secondary School, Senior Secondary School 2, we are going to be dealing with another episode on circle theorems, and this will be a second episode we'll do on circle theorems. Now in this other episode of circle theorems, we'll be dealing with tangents, and this tangent deals with the circle theorems that deal with tangents. Now a tangent is simply that line that cuts a circle at just one point. It meets a circle on only one point. Now these tangents, there are different tangential theorems that are related to circle theorems, and there are three. Now as a tip for you, I will tell you that you should check out a video on this channel, this very channel, Global Education Zone, GLEDU Zone. There's a video where I've talked about the derivation of every tangential theorem, the tangent theorem, both the ones of alternate angles and all the rest. So I've proved all the theorems if you are looking for the proof, and then I've also solved calculation in detail in another videos. So if you are looking for further calculations and you have further problems, you can always check the videos, and then you can also check the description of this video. Most of the previous videos, I inserted my phone number, my mobile phone number, so you can also contact me if you have further problems and further questions. So for today, we are going to do a revision of those theorems, and the first of those theorems we're dealing with is the fact that a tangent to a circle is perpendicular to the radius drawn to the point of contact. So what this means is that when you draw a tangent to a tangent meets a circle at a point. So when you draw a line from the center of the circle to that point where the tangent met the circle, it's going to meet it at that point, and that point is a point of contact. So that point of contact, the angle between the radius that is drawn from the center of the circle to the point of contact, the angle between that radius and the tangent will be 90 degrees. So the tangent will always meet that radius at 90 degrees, and the converse is also true, because anytime you draw a 90-degree angle from the point of contact of the tangent to the center of the circle, it will always pass through the center. So that's the first one. And then the second one we're dealing with is that tangents to a circle from an external point are equal. They are equal in length. So I've proved this theorem in sufficient detail in a previous video of this channel, and I don't want to repeat it, so you can also check that video. So now we also have the last one we're dealing with is if a straight line touches a circle and from the point of chord is drawn, the angle that the chord makes with the tangent are equal to the angles in the alternate segment. So what this means is that if a straight line is drawn to meet a circle at the point, and if a tangent is drawn to a circle and from the point of contact of the tangent you draw a chord to the circle, now the angle that chord makes with the tangent will be equal to the angle in the alternate segment. Now I will be solving a question based on these three theorems, and this question I'll be solving will be one that will satisfy these questions and also make it easier for you to understand how these theorems play out in mathematics. Now the question says AT is a tangent to a circle ABCD. Now let this be the circle ABCD. Now this will be AT. This point A, AT is a tangent to a circle, and then we are again told that angle BAC is equals to 64 degrees. Now let this be B. Let's call this B. Let this be B. Okay, from B to A. Okay, B A C. Let this be B. B A C. Let's call this C. It's 64 degrees. Then lastly, we also have that angle, and CAT is 72 degrees. So angle CAT, that's angle CAT, the angle drawn from here to here, this will be 72 degrees. Right? From what I have here, it's 72 degrees. From what I have here, 72 degrees. So that means now we have to calculate the value of BCA and CDA. So we are looking for BCA. We are looking for the value of this angle, and then CDA. Let it be DA, the value of this angle, CDA. So we are looking for this angle and this angle. Now you have, let this be, we don't have a radius here now, but now this the angle drawn, the line drawn from this tangent to meet the circle, it meets the radius at 90 degrees, right? Now this angle here is the angle that is formed at the alternate segment. This angle here is equal to the angle formed in the alternate segment. So this one will be equal to the angle formed in the alternate segment. Now let this be X, and let this be the angle Y. Let this be Y. So you can see that from the sum of angles in a triangle, x plus y plus 64, x plus y plus 64 degree equals 180 degree, because angles in a triangle is 180. And at the same time, x plus and at the same time y is equals to what? Because this angle equals to this angle here, and this angle here is equals to 72 minus x. So y is equals to 72 minus x. So now we've set up an equation here. We can also say, okay, so if y is equal to 72 minus x, now that we have an equation here, 72 minus x, so we can say this 72 minus x will be equal to our y here. We can also say 72 minus x equals 72 minus x equals y. So let me check the question. So I just cross-check the question now, and actually this angle BAT is actually 72. So that means if angle BAT is 72, that means this 72 will be equal to the angle in the alternate segment. That means angle ACB will also be 72. That's one of the theorems of circle geometry that's linked on tangent. So if this is 72 and this is 64, we have to look for the angle ABC. So angle ABC, let's clean this up. This is wrong. So angle ABC plus angle ACB, which is 72, plus angle CAB, which is 64, will all add up to 180, because the sum of angles in a triangle is 180. So ABC equals 180 minus 72 minus 64. So ABC equals 180 minus 136 degree. That would be what? 44 degrees. So angle ABC will be 44 degrees. So this is simply how this works. Now, doing what I just did now, this angle TAB, it is the angle formed between the chord AB and the tangent AT. So this angle here, it is equal to the angle in this alternate segment. That is the angle formed subtended by this chord in the opposite segment of the circle, or the alternate rather. And this alternate segment, it is formed just between the circumference and this chord AT. So this angle here, angle ACT formed, will also be equal to the angle formed by the tangents and the chord. So 72 here will be 72 here, and then we use that knowledge to solve for the angles missing in the circle. So thank you for watching, and see you next episode.